When we talk about exponent rules, we have the idea that 5 squared is 5 times 5, or 25. We know that 4 to the third would be 4 times 4 times 4, which would be 64. But what if we had two things? What if we had something like 3 to the fourth times 3 squared? We could expand it out and make it 4 3s and 2 3s that comes together to be 3 to the sixth. But do we really need to break that apart each time, or just notice that we're adding the exponents to get our answer? So when we have like bases, or the same base, we add exponents. And that's the first rule that we have to start with. So what if we went to something like 8 to the third and 8 to the sixth? That says we have 3 plus 6, or 8 to the ninth. If we had 9 to the sixth, 9 to the negative fourth, and 9 to the negative 2, we're just going to add them all for the exponents because they all have the same base of 9, and we get 9 to the 0. Now what is 9 to the 0? Well, what is anything to the 0? Any base that we have to the 0 when it's a real number turns out to be 1. Anytime we have something to the first, it comes out to be itself. So we can start to build upon this and maybe get a little bit more. What if we then had some coefficients involved? 5x to the fourth, x to the ninth, and 3x turns into a problem where we write the coefficients first and then our exponents. I have 4 plus 9. This is a 1 because there's nothing there, so we can't forget that. So our answer is going to be 15 x to the 14th, because 4 plus 9 plus 1 is 14. Next, let's go to negative 4, 7, and 2, c to the third, d to the second, and c to the negative 2. Well, 4, 7, and 2 multiply out to be negative 56. Then I have c to the third and c to the negative 2, which is just c, and d squared. So negative 56 cd squared. Next, we have 5 times 3 times 3, x to the fifth, y to the sixth, x to the second. These two are 9 times 5 is 45. Then I have x to the seventh, y to the sixth. So with separate like bases, we add the exponents. The next rule we get to is what if we raised a power to a power? If we're raising a power to a power such as a to the m to the n, or a to the m, it becomes a to the m times n, or 5 to the fourth squared, it's telling us we have two 5 to the fourths, which becomes 5 to the eighth. That is the same thing as multiplying the two to get to our result. So now it's an exponent to an exponent, or a power to a power, we're going to multiply the exponents. Now we can even go a step further, and what if it became raising a product to a power? So what if we had multiple terms involved? What if now it was something like 3x to the fourth? 3x to the fourth is saying we have 3x, 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 and 3x 4 times, which is 3 to the fourth and x to the fourth. So this is kind of like distributive property. It's not distributive property, but it's kind of like it, where you're going to multiply it in to each of your terms and apply the exponent. And where it changes is if it already has an exponent. So let's look at a couple examples. If I had x to the fourth to the fifth, that means I have x to the fourth 5 times. Now together that's 5 sets of 4 comes out to be x to the 20th. But really the rule, or the shortcut, says you just multiply 4 times 5 and you get the 20th. Now we'll talk about fractional exponents a little bit later, but right now we could at least multiply x to the 2/5 to the 10th. We'd multiply. That gives us x to the 20 over 5, which is x to the fourth. 7m to the ninth, 7m to the ninth to the third. Apply to the 3 to the 7, apply it to the m to the ninth. Don't forget to apply it to the 7. That's a common mistake. So we get 7 to the third, m to the 9 times 3 becomes 7 to the third, m to the 27th. Now we get a little bit more to it. So what I like to do on these problems is simplify the exponent to exponent, the power to power first, and then put it together. So here I have x to the negative 4, because it's negative 2 times 2. Then it's going to be 3 to the 4th, x to the 4th, and y to the 5th to the 4th. Now you got to multiply those two, and that becomes y to the 20th. So now we're looking at 3 to the 4th is still there. Then I have 4 and negative 4, which is just going to become x to the 0, and then y to the 20th. Well, we said earlier that x to the 0 is 1. That doesn't mean it becomes x to the 1. It just becomes 1 itself. And then since we are multiplying, it's gone, and our answer is 3 to the 4th, y to the 20th, or 3 to the 4th is 81, y to the 20th. Our last one. Now this one's sneaky because it puts this part right in the middle. So let's focus there first. It's going to be 2 to the 3rd, j to the 33rd. Bring down my other terms. So now I have 4 times 8, which is 2 to the 3rd, j squared, k to the 6th, j to the 33rd, k to the 5th. This is now 32 from 4 times 8. I have 35 j's and 11 k's.